Okay, so I've already done some work for you. The first step here is if you want to find the eigenvalues and eigenvectors. I've already done that for you, and I've written down the general solution. And so now I just want to sketch some solution curves. So let me draw the x1, x2 plane. We'll say this is x1, this is x2. Okay, so when we do this, we're first going to draw some lines through the origin that are parallel to the eigenvectors. So the eigenvector 1, 1, that's v2. It's kind of, at a 45-degree angle. This represents V1, and then, V2. And then V1, that's 2, 3. That's going to be a little steeper. The slope is 3/2, which is bigger than 1. And so this is V1. Okay, now the idea, we're going to kind of think through it this way. So I'm not going to go through all the details. You can look at the class videos for that, or the notes, or the book, or whatever. Okay, but what's going to happen to x of t as t goes to infinity? So let's say we have a solution starting here. What's going to happen as t goes to infinity? Well, notice that x of t is going to go to the origin, because e to the minus 2t and e to the minus t both go to 0 as t goes to infinity. But notice what's going to happen. E to the minus 2t and e to the minus t are both small as t gets bigger and bigger and bigger, but e to the minus 2t is way, way smaller than e to the minus t. Okay, and so this means that this is going to be the dominant term for big positive values of t. In other words, the vector or the solution is going to go to the origin and is going to be parallel to the vector 1, 1. In other words, v2 as t goes to infinity. So it'll look something like this. Okay. On the other hand, if we think about kind of going in reverse, going as t goes to negative infinity, e to the minus 2t and e to the minus t are both big for big values of negative t, but it's the e to the minus 2t that's even bigger for big negative values of t. And so the solution is going to be parallel to the vector 2, 3. In that case, this is the dominant term. And so it's going to look something like this. So it's going to be parallel to the vector v1. And we draw an arrow there indicating that is the direction of travel as t increases. That as t increases, the solution gets traced out this way. Okay, so if we have a solution starting here, we're going to have something similar. As t goes to infinity, it's going to go to 0 in a way that is parallel to the vector v1. And then as it goes to negative infinity, if you think about it going to negative infinity, it's going to get more and more parallel to v2. That's the direction of increasing t. And then we'll have something like this. It's a little easier. It's a little harder to discern, actually, when you're in this. When you're right here. And then something like this. And again, they're traveling into the origin, so that we're going to put the arrows in that direction because that is the way that the solution curve gets traced out. Okay, that's it for this video. I know some of this is kind of quickly, but to get more of the theory, you're either going to have to look at the class notes again, look at the class video, or read the book.